Hello, good morning. In the previous class, we have studied gravitational expression for the gravitational potential and gravitational field intensity due to the solid spherical shell. And in that, we are we had understand four types of cases. Case 4 at a point P outside the spherical shell. Second case at a point P inside the spherical on the surface of the spherical shell. Case number 3 inside the spherical shell at a point P inside the spherical shell, and at the fourth at the center of the spherical shell. So all these four cases we have studied in the previous class, and in the today's class we will see the next topic, that is the gravitational self energy of a body. So gravitational self energy of a body. So every body has the gravitational self energy. The body has the gravitational self energy due to its mass. So because body has a different types of mass and different, so that's why unique body, and it is one body, particular body has the particular self energy, and it is due to the mass. So if the mass is different, then gravitational self energy is also different. So it is equal to the work done. It is equal to the work done by the gravitational force. It is nothing but the work done. Energy is nothing but the work done. So this is the gravitational self energy. So this is also the work done by the gravitational force in bringing a infinite small masses. In bringing the work done by the gravitational force in bringing the infinite small masses that are initially at infinite distance from one another to a point where the body is formed. So the gravitational self energy, it is equal to the work done by the gravitational force in bringing infinitely small particle which is initially at infinity okay, which has the small bringing the small particles or small masses. Here we write down small masses which are initially at infinity or the infinite distance from one another okay, in bringing infinitely small masses which are initially at infinite distance from one another to a point where the body is formed. Okay, so this is called the gravitational self energy of a body. It is nothing but the work done by the gravitational force in bringing infinitely small masses which are initially at infinite distance from one another, and it is bringing to a point where the body is formed. So this is called the gravitational self energy of a body. Then expression for the gravitational self energy. Expression for gravitational self energy of a body. Okay, so here in the definition we are considering infinitely small masses. Okay, so for that, suppose a body consists of n number of particles n number of particles of masses capital M1, M2, M3 and which has the masses last M1. Okay, means the body consists of, suppose the body consists of n number of particles where the masses M1, M2, M3 up to Mn. Okay, so in the gravitational field each body or each particle has the gravitational field. Okay, if we are considering here M1 body of mass M1 body, so M1 body has the gravitational field, M2 body has the gravitational field, M3 body has the gravitational field. Means in the gravitational field of each particles the remaining particles are situated. Means this is the gravitational field of M1, where gravitational field of M2, because these are infinitely distance and we have to bring this mass as a body where the body is formed. Then again this is the M3. Okay, so means in each particles in the gravitational field of M1 they are situated M1, M2, M3, M4, M5. Means each particles situated in the gravitational field of one particle. In the gravitational field of each particles, in the gravitational field of each particle, in the gravitational field of each particle, remaining particles are situated. Remaining particles are situated. Okay, so if you are considering first particle, that is M1 particles, then remaining particles means M2, M3 up to Mn particles are situated in the gravitational field of M1. Okay, so in the gravitational field of M1, so first here each particle means first in the gravitational field of M1, in the gravitational field of M1, okay, in the gravitational field of M1 the potential energy of remaining particles, the potential energy of M2 remaining particles means that is M2, M3 up to Mn. Okay, because in the gravitational field of M1 particles remaining particles are situated, therefore the potential energy of remaining particles M2, M3, Mn is given by and it is denoted by the letter U1 because it is for the M1 particles, therefore the U1, and we know that is the minus G. Here the combination of M1 with M2, so that's why we write here M1 M2 divided, and radius distance between this M1 and M2, that is the R12 suffix R12. Okay, plus then the remaining distance between these masses M1 and M3. Okay, so therefore the combination of M1 M3, here the 2, here 3, divided by distance between this M1 and M3, that is R13. R12 distance between this M1 and M2 particles. Then this is the distance between this M1 and M3 particles, that's why we write here R13. Then again M1, here the 3, here we write 4, and the distance R14 plus dash here M1, that is the first particle M1, and remaining Mn divided by distance of 1n. So this is the potential energy, and in this here in the all M1 is common, So that's why we're taking here outside the bracket, that is G M1 and remaining M2 by R12 plus M3 by R13 plus M4 by R14 plus up to Mn, that is Mn by R1n. Okay, so this is the next step, and this is the summation. If we take this all in the one form, that is 2, 3, 4, 5, 6, 7, 8, 9 up to n, and here the distance R12, R13, R14, R15, R16, R17 up to R1n. So that's why we write here minus G M1 and summation. Here the summation term we write here this all 1 to n, that is the J is equals to 1 to n. Okay, J is equals to 1 to this 1, 2, 3, 4, 5, 6, and here we write here Mj divided by R1j. Okay, and here important terms, this J is not equal to 1. Okay, so this is the first potential energy. First potential energy, that is in the gravitational field of M1, the potential energy of remaining particles, that is the minus G M1 summation J is equals to 1 to n Mj divided by R1j. Okay, so this is the first number. Then again, the potential energy in the gravitational field of M2, the potential energy of M1, M3, M4 up to Mn, and this gives to minus of, here we take here U2 for the M2 is equals to minus of G M2 here. Okay, according to this G M1 for the M1 particles, and here M2 particles, they are the G M2, and summation here J is equals to 1 to n, and here Mj divided by R2j here, because distance between 2 to 1, and here J is not equal to 2, because distance between 2 to 2 we cannot calculate, so that's why J is not equal to 2. Here J is not equal to 1, means distance between second particle to the first particle, second particle to the third particle, not second to second, so that's why here J is not equal to 2. Then again, in the gravitational field, this is the second number equation. In the gravitational field of M3, the potential energy of remaining particles, that is U3, is equal to, this U3 is equals to minus GM3 as usual, minus GM3 summation J is equals to 1 to n, here Mj divided by R3j, and here J is not equal to 3. This is the third number equation. Okay, so these are the potential energies of the remaining particles due to the M1 particles, M2 particles and Mn particles. Then again for the Un, means that in the gravitational field of Mn, or we cannot calculate this and so on. So if we calculate the gravitational self energy of the body, so we have to take the sum of this u1, u3, u4, u5, that is u1, u2, u3. If we taking the sum of this all potential energy, we get the formula for the gravitational self energy, and this formula we calculate in the next class. Thank you.